Hi everyone, I Kruti Jai Pancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about microwave engineering. Today we are going to discuss about the basics of impedance matching. For the maximum power transfer from source to load, the resistance of the load should be equal to that of the source. The reactance of the load should be equal to that of the source, but opposite in the sign. You have studied these things in the case of the maximum power transfer theorem. So for the impedance, I said that the maximum power transfer from source to load, the resistance of the load should be equal to that of the source. Now if the source is inductive, the load should be capacitive and vice versa. Now when this condition is satisfied, we say that impedance matching that has been achieved. So there are the several methods to achieve the impedance matching. So out of that, the components used are referred to as an impedance matching device, or in a transmission line, impedance matching lines that can be used. As we know that we have studied about the characteristics impedance also earlier, that when the characteristics impedance mean it is the impedance at which the reflection would not occur. So we don't want the reflection at the source end. So that is why the impedance matching that can be the very important task while we are studying about the microwave engineering. So generally the signal source that having the fixed impedance and impedance matching that can be used for reducing the reflections. So that is why this kind of the method that can be used. The transmission line having a length of lambda by 4 quarter wave line or lambda by 2 half wave line have special properties, and that can be employed for the impedance matching purpose. So for a quarter wave line, an odd multiple of the Z by 4 and the impedance of the ZS that looking towards load is given by Zs is equal to Z0 square upon ZL. So the source impedance is equal to the square of the characteristics impedance divided by ZL. Here is the example of the dipole antenna. Now this dipole antenna with a resistive input impedance Rs. This Rs that can be matched to the main transmission line having the characteristics impedance Z0. So by the means of quarter wave line or the quarter wave transformer having the characteristics impedance Z0 dash, we can match it that Z0 dash value should be equal to square root of Z0 into Rs. The simple quarter wave transformer suffers from the disadvantage of being sensitive to change in the frequency. That is why at a new wavelength, the quarter wave section will be no longer lambda by 4 length, and in such cases, 2 or more stages of lambda by 4 line stages may be required for increase the range of the frequencies in the impedance matching. So therefore, a lambda by 2 transmission line can be used for the matching purpose. If the load is placed at the far end of a half wave line, the input source impedance will be equal to the load impedance. This property of the half-wave line is applicable to low loss lines. If it, however, has the disadvantage of half-wave line, that is the frequency dependence and independent of characteristics impedance. It is having the advantage, that is of helpful when we need to set a line at a point which is not physically accessible. Now, which kind of the line that can be feasible during the impedance matching? A lambda wide transmission line shorted at the far end looks like an open circuit at the other end and behaves like a parallel tuned circuit. So it is like this is the lambda by 4 short circuited line. So this line is short circuited. The length of the line, it is the lambda by 4. Just a minute. So it's a lambda by 4 line, and while it is short circuited at the far end, this will behaves like a parallel tuned circuit which consists of the capacitance and inductance. So this is L, it is C. So you have to remember these things. People can ask in the Viva also. So it is what? It's a parallel resonant circuit. Now next, in the impedance matching 2, a lambda by 4 transmission line open circuited at far end looks like a series resonant circuit. So now that will behaves like a lambda by 4 transmission line. So this is my lambda by 4 transmission line which open circuited at the far end. Okay, so this is open circuited. So while the lambda by 4 transmission line open circuited at the far end, it behaves like the series resonance circuit. Series resonance circuit means which consists of the inductance that is in series with the capacitance. So here, just a minute. So it behaves as a series resonant circuit. So this is the series resonant circuit. Okay. Next is the impedance matching 3. In that, a short circuited transmission line less than lambda by 4 long will act as a pure inductor. So now next is it is the line short circuited transmission line. So what I am doing, I am short circuiting it. It is less than lambda by 4. So I am writing here it's a less than lambda by 4 line. Okay, and which is short circuited. So this kind of the line that will act as a pure inductor. So this is what? The pure inductor. So we have to keep in the mind while we are doing the analysis of any transmission line. Next, impedance matching 4. A open circuited transmission line less than lambda by 4 long will act as a pure capacitor. So now again we will draw that the open circuited transmission line. So now this is my line. Okay, it is the two parallel conductor, that's a transmission line. It's a open circuited. Okay, this is the 2 point in my transmission line, and I will just say that it's less than lambda by 4 long. Okay, and what it will do? It will act as a pure capacitor. So it will act as a pure capacitor. Next, impedance matching 5. A transmission line greater than lambda by 4 long short circuited at the far end looks like a pure capacitance. So a transmission line greater than lambda by 4 so this is the transmission line. I am assuming that it is greater than lambda by 4. Okay, and it is the short circuited. So this will act as a pure capacitance. Okay, next is impedance matching 6. It's a a transmission line greater than lambda by 4 open circuited at the far end acts like a pure inductance. So here we'll draw the transmission line. So it is the two parallel conductor. Now this will open circuited and it is open circuited and the transmission line length is lambda by 4. It's greater than lambda by 4. Then this kind of the transmission line that will act as a pure inductance. So this is my L and it is the pure inductor. So this way we have seen the various the comparison, okay, and how the transmission line that will look while it is the lambda by 4 or in the lambda by 2. So we can also keep in mind that the lambda by 2 line open circuited at the far end looks like an open circuit at the another end. So it is about the impedance matching basics. Okay, in the next video we will learn about the equations. Thank you very much everyone.